again in this second part of session 3. We already had a very nice keynote speaker and a very nice panel discussion this morning about the processing and the production of products. And now we will move on to this next panel, which will focus on the bioproducts of the future. Yesterday, John Bell of the European Commission mentioned that bioeconomy is really the catalyst, the enabler of the Green Deal. And the Green Deal means that we are moving towards climate neutrality and circularity. So this climate neutrality and circularity must pop up via our products as well. This morning, we already heard about the processes that some of the companies are trying to become climate neutral even much before 2050. So it's about the processes, but also our products, of course. The feedstock needs to become climate neutral, and there also circularity is getting very important. And this morning, we already heard also via the Andritz Laroche presentation of Elias Juncker that recycling all kinds of fibers is on the move, and we would like to introduce this recycling and this climate neutrality issues in the products that we will present today. So that's really the theme of today, climate neutrality and circularity for the product. So it's not just nice to have a bio-based product, it must also become climate neutral and circular. And before we start the panel, I propose you that we listen to Constance Ißbrücker, who will give us a short introduction on the recycling and recyclability of bio-based plastics. Constance is head of the environmental affairs at Bioplastics Europe department and is also the deputy managing director. She is responsible for issues regarding sustainability, biodegradability, standardization, and certification of bioplastics. Constance holds a degree in chemistry from the University of Jena in Germany, with specialization in bioorganic and macromolecular chemistry. Before joining the association in 2013, she worked in different research groups at universities in Berlin and Jena, where she gained valuable experience in the modification and analysis of polysaccharides, derivatives, and the synthesis of chiral amines by biocatalytic processes. Constance, I like to give you the floor, but it's more especially the camera that you have.
Yes, many thanks, Ludo, for the kind introduction and also for the invitation to speak in this panel today. Actually, as you see, I will speak on the recycling of bio-based plastics, and actually only on the end-of-life options of bio-based plastics. You could speak at least 1 hour, I would say. I have now 15 minutes, so I will try to put the most essential things into this 15 minutes. But nevertheless, give me some time to introduce European Bioplastics if you do not know them. European Bioplastics is an industry association, and the association has been founded already early in the 90s, and there was a strong focus on biodegradable materials and also only on the German markets. But over the years, the association grew more and more. The focus changed very much to the European market. The members came from all over the world. Nowadays, we have more than 70 members, actually. And as I said, the focus is on the European market, on European policy. And our common goal is to bring bioplastics forward in Europe. A short overview of the members. It's not all members of European Bioplastics, but I would like to see, because we are very proud usually saying that we represent the whole value chain. So some of our members are dealing with renewable raw materials or green chemistry, so very much at the beginning of the value chain. Then also some bioplastics manufacturers and auxiliary manufacturers are our members. Converters, of course, And I'm always happy to mention that also some brand owners are a member of European Bioplastics, because we always see brand owners as the bridge between the actual producers and the consumers. Yeah, and not to forget also certification bodies. For us, it's very important that products are complying with standards and are certified according to the standards. And also some research institutes are part of our association, so we get always in touch what's here done in research and development. Usually there's a lot of confusion about the term bioplastic, so I would try to clarify it with this picture that probably some of you have already seen. So the simple definition for bioplastics is bioplastics are bio-based, biodegradable, or both. So here you can see in this upper left corner materials that are not biodegradable and fossil-based are of course not bioplastics. But then we have materials that are bio-based but not biodegradable, for example, bio-based PE. These materials are sometimes also called drop-in solutions. Then we have a large group of materials that are biodegradable and bio-based, like PHA, PLA, and so on. And there's also a small group of materials that is still fossil-based, but still biodegradable. Because biodegradable is not dependent on the feedstock that is used, but on the chemical structure. And here on the right side, I have tried to clarify these terms again. So if I speak about bio-based, it's referring to the renewable feedstock. If I speak about biodegradable, this is about the ability to be metabolized to carbon dioxide, water, and biomass in a defined environment. And then you might also hear the term compostable. This is a certain type of biodegradability, namely biodegradability under industrial or home composting conditions. Currently, we have around about 2.4 million bioplastics in the market. Most of them are biodegradable. Almost all of them are bio-based. These 860,000 tons you see here are bio-based, non-biodegradable materials. And you also see that we expect a certain growth in the next year. And in 2026, we expect 7.6 million ton bioplastics on the market globally. This is mainly due to expected growth in Asian countries. Bioplastics are already used in many applications, just as conventional plastics, mainly in packaging, flexible and rigid packaging, but you will also find it in consumer goods, fibers, agricultural products, also in the automotive, building and construction, or in electrics and electronics. What are bio-based plastics made of? So you have different kind of feedstock. Usually these are crops, agri-based crops like sugarcane or wheat. Then also castor plants are used, for example. More and more, there's a tendency to use more non-crop solutions, cellulosic-based materials, that could be waste materials or wood. And also sometimes waste is already used to produce bioplastics. Nevertheless, very often there's the question how much land is now used for the production of bioplastics. And if you have a look at the whole global agricultural area, that's around about 5 billion hectares, you can see with the market data I showed you in the previous slide, in the last year, 1.7 million hectares have been used for the production of bioplastics. So that's 0.013% of the whole global agriculture area. And even with the expected growth, we will not see more than 0.06% used of global agriculture area in the next years. Now, looking at the end of life, what my presentation actually is about, this is the European waste hierarchy. As you see, also for bioplastics important, on the top of the hierarchy should be prevention and minimization. Bioplastic can support this through improved barrier properties. There are materials that show better barrier properties than conventional plastics. Second step we know is reuse. Bioplastics offer multiple and cascading use with regard to certain applications. Third step is recycling. This I will tell more about in the next slides. Then, of course, recovery is an option. Incineration. Here, if you use materials made of bio-based feedstock, you have a generation of renewable energy. And last and not so much liked step is, of course, the disposal. So landfilling, we as association, we support the gradual phase of waste, at least of recyclable waste everywhere, because, of course, it also contributes to the littering problematic. That was too fast, sorry. Yeah. So here now an overview of the recycling options for bio-based plastics. I will start in the middle because this is what most people know, mechanical recycling. You do mechanical recycling, it will result in recycled and polymer, in the recycled polymer and plastic. There's also an option which is called solvent-based purification. This is also for bioplastics, so polymers are dissolved. But the polymer chain is still in place, and here you also will receive a recycled polymer plastic. Then you can, of course, you have chemical recycling, which is a very interesting technology. You can distinguish, for example, in chemical and solvent-based depolymerization methods or in thermal depolymerization. Here you usually get new chemical raw materials, which can then also be used to produce bioplastic. And then very special for bio-based plastics that are biodegradable or better compostable. Here an option comes into place called organic recycling. Organic recycling will result in carbon dioxide, water, and biomass. Let's have a closer look into the mechanical recycling of bio-based plastic. This is the preferred option actually for the drop-ins materials such as bio-PE, bio-PP, or bio-PET. And these materials can be processed in the existing recycling stream without any problems. The recyclate you will obtain by the recycling of this material will have the same quality and the same mechanical properties as the fossil-based equivalents. But it's probably interesting to know that also some new innovative materials such as PLA can also be mechanically recycled and are in a small amount already are mechanically recycled. Usually for mechanical recycling, you can use sorting technologies like near-infrared. Near-infrared can easily identify different kind of polymers, also biopolymers, and therefore help keeping the streams clean. So if there are contamination issues, this is something you sometimes hear that biodegradable compostable plastic might disturb mechanical recycling streams. If you have good sorting technologies in place, this is not a problem. And in general, contamination is a problem of all kinds of polymers, not only biopolymers. So each and every kind of polymer can disturb a certain stream if it's not properly sorted. As I mentioned before, also chemical recycling is a good option also for bio-based plastic. It helps keeping renewable content in the loop and therefore, of course, supports the approach of a circular economy and helps also to provide high quality recycled bio-based plastics. In the end, it helps also requiring not only fewer fossil resources, but also less renewable feedstock to produce the new high-quality bio-based plastics. Currently, for bio-based plastic, it has been shown most efficient is the thermal conversion to gasoline or the chemical depolymerization. And in different studies and projects, it has been shown that it's, of course, easily applicable to drop-ins, such as the bio-PE, but also PLA can be chemically depolymerized and then reprocessed to lactic acid, which can then be used to produce a new PLA. Then also an interesting project showed that if you have a kind of mixture of polymers like PLA and PET, which is not necessarily something that is desired, the chemical recycling can also help to separate those polymers. And having a look at the organic recycling. So actually, people often ask, what is organic recycling? So there's a definition in the EU legislation of packaging and packaging waste. Organic recycling shall mean the aerobic composting or anaerobic treatment under controlled conditions and using microorganisms of the biodegradable parts of packaging waste, which produces stabilized organic residues or methane. Landfill should not be considered a form of organic recycling. So this is an official definition of this term organic recycling. For our industry, it's important that if we call a material organically recyclable, it should comply with the standards. It's even a harmonized standard, this EN 13432. It's a standard specification including requirements regarding disintegration, biodegradation, also ecotoxicity tests, also requirements regarding heavy metal content for compostable packaging and plastics. This organic recycling can help to optimize the separate collection of bio-waste. So if you use, for example, compostable bio-waste bags, usually more bio-waste is collected, which of course supports then the collection of bio-waste. In general, it supports also the diversion of bio-waste from other waste streams. So less bio-waste will end up, for example, in incineration or in the mechanical recycling. Furthermore, there is a reduction of the impurities in organic waste collection. So the more compostable plastics are used, the less conventional plastics you will find in the compost. And to have at least a small look at the recycling context as we usually know it, the compost that is produced and the waste that is collected can be a new raw material for industrial purposes. You have organic fertilizer if you use the compost, but it can also be used as a new feedstock for bioplastics. This is an overview. It's actually my last slide, an overview that we have prepared to show all this end of life options for bioplastics. Here you see again, the reuse should be the most important possibility with plastics. Reuse ranks higher than recycling in the waste hierarchy and should always be considered first. Then the three recycling options. So mechanical recycling recovers bio-based plastic waste through mechanical processes to recreate resins without changing the chemical structure. Chemical recycling comprises different varying technologies that convert bio-based or conventional feedstock plastic waste into an upstream feedstock, resulting in secondary raw materials that have the same quality as virgin materials. And I also introduced you to organic recycling, which includes two technologies, industrial composting and anaerobic digestion, and compostable plastics save valuable organic waste from landfill and incineration and help turning waste into beneficial high-quality compost. And just as a last point, I also mentioned it before with the waste hierarchy, energy recovery. Of course, if no recycling is possible any longer or is not in place, then energy recovery is, of course, the preferred end-of-life option. And here it helps that biogenic carbon is used in the materials because therefore you just turn back the carbon dioxide that has been initially taken up from the plant that is used for the production of bio-based plastic is set back to the atmosphere again. Okay. Then if you want to learn more about bioplastics, Urban Bioplastics also has a conference every year, this year in December. If you're interested, feel free to look at the site and have a look at the program that we will publish soon. And this just keeps me to say thank you for your attention. And yeah, I'm looking forward to some questions maybe.
Yeah, Constance, thanks a lot. I'm really happy that you focused on the recyclability of bio-based polymers because very often people, when they speak about bio-based polymers, they only think about biodegradability. And so I think in view of the theme of this session and also of the theme of the whole forum, where we are looking to climate neutrality, it really can make sense that we replace more and more gradually fossil-based plastics by bio-based plastics. And we will never have enough biomass if we do it so, unless we do this recycling. So I think that's really the point. And therefore, my question is, do you believe that on the long term, this could be possible, that every year we bring more bio-based plastics in the cycle and then start to recycle so that at the end, maybe by 2050, we have a full circular system only running on bio-based plastics in a circular way and not anymore fossil-based?
Yeah, that would of course be an interesting option, at least for our industry, if this would be the future. I mean, already many years ago, it has been shown that most plastic applications, I think around about 85%, maybe even more nowadays, can be replaced by bio-based options. And looking at the circular economy, at the idea of circular economy, of course, recycling should always be first. So materials should be kept in the loop as long as possible. But this is also a fact, especially looking at mechanical recycling. You cannot recycle a polymer forever. It will lose quality. Every once in a while, you will need virgin material. And here, of course, bio-based plastics should be the preferred option. I mean, we know about climate change. We know we need to get rid of fossil materials. So, of course, it makes sense if you need a virgin material to look into bio-based options.
I have another question about the composting, but I will keep that for the panel discussion, but maybe something else linked to your slides. You showed that the land impact is nowadays very limited, and even by 2060, it will be 0.058%. But if we really move to plastics, to bioplastics that will have impact, do we expect then that still land impact will be limited? Because nowadays, okay, the concentration or the share of bio-based plastics in the whole amount of plastics is also extremely limited, of course. Do you see there a risk for the future?
I mean, I think we all agree that if you use biomass to produce materials, or in general, it should be sustainably sourced. You should have a look into several sustainability issues, also look into biodiversity issues, for example. But to maybe bring it down to a figure, the University of Wageningen has published a figure which showed if we really replace all plastics with bioplastics, then actually the amount used of the global agriculture area would be 5%. Of course, this is still a lot compared to now, but overall it's still an acceptable amount. On the other hand, and the industry is, of course, as I said, looking more and more into using non-crop feedstocks. So this will also contribute to keep the figure overall low over the years.
Thanks a lot, Constance. I hope you can stay with us for the panel discussion so that we can move on further with that point. And I think 5% is not so bad. If we decrease a little bit the consumption of meat, we are already there. So thanks, and please stay with us for the panel. As mentioned this year, the World Bioeconomy Forum is really focusing on these climate issues of biotechnology. And in that way, I invite also our panelists to show their vision and approach on the development and marketing of bio-based products in function of climate mitigation.
Ludo, I'm sorry,
I think there is a question.
Two questions, please, from the audience.
Okay, perfect.
Question number one to Constance, please. Are there own collection systems available for bioplastics just now or not yet? Are they all mixed together with all the other recycling things?
It depends a bit on what kind of bioplastics you look at, because if you look at the already mentioned famous drop-ins like bio-based PE, you can just collect them with the fossil-based options. If you're looking into compostable options, the idea is not to collect compostable plastic and to compost them. The idea is to use compostable plastics to collect more bio-waste, and applications like, for example, I mentioned the bio-waste bags, or for example, fruit stickers could be made of or are already made of compostable plastics. And by using these kind of applications, more bio-waste is collected, and then they will be composted with the bio-waste if they are allowed to be collected in, for example, bio-waste collection.
Okay, thank you. So thank you very much. And question number two. What is the minimum amount of bio-based material to make it economically feasible to recycle it? Is there a number you can tell us What should be the amount?
No, actually, I can't. I'm happy to think about it and maybe also discuss with my colleagues and our members, and yeah, maybe give a written answer, but not spontaneous.
Okay, thank you.
Thanks, Constance, and thanks, Matthias, for interrupting me. So we move on now with our panel, and I will present the panelists one by one, and they will give a short presentation of maximum 5 minutes, and then we move to the discussion. So we will start with an ethanol-based company, Sekab, that has developed technology to convert, and we stay in the waste discussion, bio-waste into platform chemicals for fuels and chemicals. They are increasing their production to meet the demand for sustainable products, so that's good news, I think. And therefore, we invite Ylwa Alwarsdotter. She's the EVP of Business Development at Sekab Biofuels and Chemicals AB. She's the chair of BioChem Europe, a sector group of CEFIC, and she's member of several groups in the field of bioeconomy, sustainability, trade and industrial policy within CEFIC. And she's also member of LSB, Advanced Biofuels Coalition, advocating advanced biofuels made from residues and waste materials. Ylwa, I give you the camera.
Thank you very much, Ludo, and good morning, everyone. I'm very happy to have the honor to make a short presentation about Sekab, but I will also take the opportunity to talk about the hurdles we have seen, because just like Ludo said, we see the great demand coming, and we are early in the value chain. So we have seen now some hurdles I would like us to discuss or mention. So we are an ethanol-based chemical factory using bioethanol, and we are producing feedstocks for mainly the chemical industry, but also the pharma industry in Europe. We are using the residues to produce methane gas, which is then converted into electricity and bioenergy. So we are thinking sustainability in everything we're doing. We are shipping or sending our products mainly with ship and with train, with focus on that. We are also known for developing high blended biofuels like ED95 for trucks and buses, E85 for the Swedish market. We even imported flexi-fuel cars once upon a time. We still sell advanced ethanol, and the advanced ethanol is coming from a pulp mill. It's a residue from pulp mill. They used to be our owners. And I'm mentioning it because this was a learning. These fuels went to the consumer market, and the consumers demanded sustainable fuels, the most sustainable we could find. So that was a learning. So we had to start to develop more ethanol. I just wanted to show you this nice picture. You can't read it, but it actually shows that once upon a time, more or less all chemicals used were produced from residues from pulping. This is sulfite liquor, and we are a part of this scheme. We are producing some of them, and I can see future that they will continue, will be uptaken again, and that's what we are working with, to produce more of them. But the technology mentioned is Cellulose, so we separate mainly, I would say, residues from the forest industries into different mainstreams like cellulosic sugars, that's the C6, or hemicellulosic sugars and lignin, and then they can go to whatever base of wherever industry you more or less want or need. Most focus we have worked with in the lignin area, but that was presented now in the morning, what you can do with lignin, but we have put a lot of efforts into value adding into the lignin. So what we are offering in the market is biochemicals, 3 products where we see now, as I said, a huge demand coming. We are offering advanced bioethanol for fuels and different blends of ethanol, but very important now is also the heat transfer fluid, thinking about the energy crisis. For example, IKEA in Umeå, north from us, they are heating the whole area with thermal energy. So they pump up energy from the ground with thermal. And then we have the biorefinery offers. studies and demonstration plant is still up running, and we're working to commercialize this technology. But as mentioned, we are seeing a great demand for sustainable products, and we also know that there are many technologies available, but most of them, and also presented today, they are flagship technology, or they are flagship stage, first of its kind. So we need the big players to step in and help to really make the big investments and give also trust, I think, for the banks and others. And we don't have any legal requirements or minimum requirements on certain certification schemes or sustainability. That is only offered within the bioenergy sector, like in the Renewable Energy Directive, but not for products, not for feedstocks, unfortunately. There are a lot of private schemes, of course, but there is a non-legal one, and the private ones are very different. So the allocations of the bio part or the boundaries is not mentioned. So this is a really big problem for the kickoff for the bio-based products. And the second one is how to calculate, since the biomass is taking up carbon when it's growing. And this is not recognized in the method the Commission normally is talking about. That is a PEF method, product environmental footprint. You cannot have the credit for the biomass unless the product in the end goes for incineration. So if it's a bio-based product delivered from gate or somewhere in the value chain, you cannot take it into account. Or if you recycle product. So a calculation can show then that fossils are better than bio-based and recycled products. So we have to have a change here, and it's urgent, because pricing, or so to say the surcharge you can achieve for bio-based product is depending on the CO2 reduction you can calculate. We have to give out the CO2 calculation more or less every day nowadays, and that's very positive, but we need to be able to calculate in the right way. Okay, so those were the two hurdles. Thank you very much for giving me the floor, Ludo.
Thanks a lot, Ylwa, for presenting your company, what you are doing, but especially for presenting also the hurdles. And you indicated that there is coming a great demand for sustainable products, and accordingly also new feedstock is needed. Apart from the hurdles, do you see that this new feedstock is available, or are there problems as well concerning the availability of feedstock?
I mean, ethanol is one of the platforms, or mainly going back to sugar, since sugar becomes an ethanol. And ethanol and sugar can be produced from more or less any cellulosic material or starch material. And we have residues all over the world. We have different kinds of biomass. And there might be few countries not having then biomass. I'm thinking about, Saudi Arabia and others. But then they have CO2. And in those countries, they also have sun, so they can produce electricity, since, I mean, you need electricity to convert it into ethanol. So if we just kick off all the technologies available, I don't think that's a problem. It will take a bit of a time, but that's not a problem. And I mean, the other, like the aromatics and where lignin can be produced from very many different kinds of waste also.
Yeah. Okay, thanks. I also would like to add that still a lot of biomass or residues nowadays are going to landfills worldwide and emit a lot of biogas, which is a climate issue, and on the other hand, a loss of energy as well.
Exactly.
Maybe the second point is you were mentioning the legal requirements concerning products. We have legal requirements concerning energy and not concerning products. How can we change this? We hear a lot of times that consumers are more and more willing or asking the manufacturing industry or the brand owners, you mentioned IKEA, to come with sustainable products.
Yeah.
Would there be a possibility that this consumer concern could have some impact on the Commission also to make this legislation or legal requirement also an issue concerning products, materials, and not only for energy?
Yes, I think that would help, putting a bit of pressure on the Commission, and there are standards also where you can take into account if it's recycled the product, if it's biomass. And we have just started, by the way, European standardization work also to be able to compare the fossils with the bio-based products and recycled products. Constance is a part of that also. So that's one way, and then we have to convince the Commission that they have to listen to us.
Yeah. Okay, thanks a lot, Ylwa. Stay with us for the panel, and we will move to the next speaker. And we will move now to the use of bioproducts in combination with other products, so-called biocomposites. And in that way, I would like to refer to to a panel discussion we had some months ago about wood use in construction. And also would like to refer to a YouTube video that we broadcasted concerning the production of glass from wood. So you can make everything from wood. And so with the next speaker, we will enter into the replacement of ceramics by wood. And for that, I invite Petro Lahtinen. He's the CEO and founder of Woodio to give us his perspective. He will give us a fascinating view to new bio-based materials, and he knows also I will ask afterwards something about the recycling of his material. So, Petro, there he is. You have the camera.
Thank you. Sharing my screen here. Yes, thank you for the opportunity to tell a little bit about the later stage of the value chain, like compared to Ylwa's. What she said that they are in the early stage of the value chain. We represent the kind of the latest stage of the value chain. So we actually make sellable products, consumable products from biomaterial-based materials. And just to give a short background to my presentation, it's not a common knowledge that ceramic industry is actually one of the biggest polluters of all industries, of course, combined with the cement industry, which is even bigger, but the ceramic industry itself emits 5 million metric tons of CO2 every year. And this is due to the fact that all the ceramic products, they are basically fired in a furnace for 12 hours in 1500 degrees or so. So that consumes a lot of gas or oil. Those are the main fuels used by the ceramic factories. And for this reason, this ceramic industry is quite large. In European Union, employs 200,000 people, and there are 4,000 factories, I guess, was in European Union area. So it's a big industry, and that's why it has been raised as a topic of concern by the European Commission as well. So basically, our company is a university spin-off. The original invention of our material was made at the University of Helsinki. Where I got my PhD as well. So I have been basically my professional career studying biomaterials and use of wood in different applications. So at the moment, Woodio is based in Helsinki. We have a demonstration factory where we test different kind of bio-based resins. As you mentioned, we use a lot of different kind of raw materials at this stage of our technology. And we are funded by EU Horizon 2020 program. So we have quite strong scientific background in our company. And about the material, we are commercializing, the main raw materials are wood chips, and then we use bio-based resins, and we use also bio-based fillers, which in essence are starch or cellulose-based fillers in the material, and we have developed a proprietary casting process. So basically we can manufacture any kind of 3D products from our material. In the first stage, they are, as said, intended to replace ceramic materials, but in the long run, we hope that we can utilize our technology in many other applications within construction as well. And here are just some images of our product, what they can look like, and our vision and mission. We obviously want to take the technology and our products to the global markets and become the world's leading eco-material design brand. So I guess that this is the short introduction to Woodio and what we are doing at the moment.
Okay, thanks a lot, Petro, for the nice pictures, and it really looks very interesting. And if you speak about innovative products, this is really a very nice example. It's really changing also, as you mentioned very clearly, the ceramic business by making these wood-based composites. So for me, it's very attractive. I suppose that you use a lot of resins in these cases. And so my question is, are they all also already bio-based, or is there a move towards it, or how will you do that for the future?
Yeah, in the demonstration plant which we are operating at the moment, we use both fossil-based resins and we use commercially available bio-based resins. We are involved with Finnish universities in development of wood-based resins. There are technologies that you can make polyester resins and epoxy resins from hemicellulose or cellulosic fractions of wood, but those are obviously coming in long term, so they are long projects. But at the moment, we try to use commercially available bio-based resins, and we are actually the first choice and kind of loyal customer of all the major suppliers who are developing bio-based resins, because we have something visible we can show. It's a little bit different to make a windmill blade compared to our products, so they kind of like our image and what we are doing.
Mm-hmm. Thanks. I think there is a lot of epoxy development nowadays. It was mentioned this morning in the case of lignin. Ylwa mentioned that lignin is available, so there are certainly very nice opportunities for the future. So, dear Petro, stay with us for the panel discussion, and I would like to move to the next one. So up to now, we could listen to what I call a typical bio companies. So let us move now to the other side and move to the chemical industry. The chemical industry is nowadays responsible for mainly all carbon-based materials that we use, and they are all, or nearly all, from fossil origin. How does such a company look to bioproducts? How do they look to recycling? And therefore, I invite Christian Haessler, Head of Circular Economy at Covestro, to give us their insights and approach. Whereas we know that nowadays Covestro is really becoming a leader at the level of circular economy. Christian Haessler got his PhD at the University of Erlangen and had a long career at Bayer Leverkusen with functions in Singapore and China. In 2013, he returned to China as head of innovation for Covestro in Asia Pacific, also heading the Regional Polymer Research and Development Center in Shanghai. And now back in Germany, he took over the global function as head of sustainability in June 2018. So this was, and so I think he is really very nicely placed to give us the view of his company towards on bioeconomy and circularity. Christian, I give you the camera. And I hope Tammy can share the slides.
Yes, thank you very much. First of all, Ludo, for the kind introduction, and hello everybody also from my side from Leverkusen. Yeah, we want to become maybe a less fossil and more bio-based company in future. So that is one of our targets. And I have only a few slides today, and we see as Covestro becoming fully circular, as our company vision for some years now, and we see circular economy really as the key enabler to both resource protection and climate neutrality. And if you could go to the next one, please. Yes, very simple slide, but let's make ourselves aware of the role of the chemicals, and specifically for us, the plastics industry. Plastics, first of all, is of course a key enabler for many, many industries. Our products go in electronics, in construction, in automotive, and many, many more. So in order for these industries to become climate neutral, we are convinced that plastics have to play a role, right? Already now in our portfolio, there are water-based solutions instead of solvent-based. There are lightweight solutions. There is insulation solutions. So they help to save energy already now. So that's a role plastics have, and it's a multiple role in various industries. But on the other hand, chemicals industry is also a major emitter of greenhouse gas emissions. So we need to address that very thoroughly. We're setting ourselves the right targets for all the scopes we have there. And of course, we have the additional challenge of plastics in the environment, which we have to tackle. Yeah? We are ourselves, in our company, we are not a lot involved in packaging business. That is often put in the center there. But also our plastics materials at the end of their lifetime, and that might be after 5 or 10 years only, might end up in the environment or are incinerated. Both is not a good solution. So we need to work on this as a plastics industry. We have a responsibility there. And if we would then go to the next slide, please. And this already is the last one, but this is a bit more detailed then. This is our concept we set up some years ago on circularity for us. And what you see here, first of all, is that currently, as you rightly say, Ludo, we are still a very fossil-based and linear company. So it starts for most of the chemical industry players on the bottom left-hand side with fossil sources, with oil and naphtha. And then we have a linear value chain that goes up via our products, and we are mostly focused on polyurethanes and polycarbonates, and then to our customers and to the end-of-life situation for our products. And there we have incineration, there we have landfilling still. Of course, there is some recycling already now established, so that is clear, but we have a highly linear value chain which we want to move into a circular value chain. And for us, and if you look at climate neutrality, you really have to look also at the raw material base of a chemical company. You just have to get away from fossil sources. It's the same as for the energy industry, also for the chemical industry. And what we want to replace fossil sources with are three categories. One is CO2 based. We will still need that long term. It is waste-based. We cannot fully switch to bio, in my opinion, because waste needs to be part of our raw material base. We want to reduce the waste in the environment, so it has to be a raw material for us. That's absolutely clear. And the third one is bio, and I come to this in a minute. First, maybe on the recycling and the waste-based solutions. You see a lot of orange bubbles here for the different recycling technologies, and that is why we need to have a variety of recycling technologies, also partly newly developed here. Mechanical recycling is established, that's true, we also do that, but for many of the polymers, due to their specific property profile, very optimized property profile, that's a strength of plastics, right? To be adjusted to the different applications with the different additives, you cannot use mechanical recycling. You will come to a downcycling, and you will not go into the original application. So you need, beyond mechanical recycling, which is set, you need other recycling types. And what is for us important is chemical recycling, might be pyrolysis even, might be enzymatic recycling. Though there's a portfolio of R&D projects to be set up together with partners to address the recycling challenge of polymers. And bio-based is a small bubble here now, but it's currently maybe, if you want, the most important one, because bio-based solutions, be it now segregated materials where we just base our polymers on biomaterials, or be it mass balanced materials where we buy bio-BTX, biophenol, and so on. This is currently for sure the biggest lever to reduce our CO2 footprint. So in order to move toward fully circular, bio-based solutions now play a very important role and will continue to play a very important role. That is absolutely clear. And what we will add over time, because recycling technologies for a good part of it have still to be developed, will be recycling technologies. And we see also long-term that CO2 has to be part of our raw material base. And we also have smaller projects that still have to be upscaled running there. And as I'm representing large industry companies here, I just want to make us aware too that this simple chart here has a volume of 5 to 10 million tons. For us, there are even bigger chemical companies, of course, 5 to 10 million tons. So that is a challenge to convert this away from fossil to other sources. And we should also not forget that the willingness to pay of the markets is crucial. All solutions we have here will cost money as either operative expenses or capital investments. And we have to have the end markets that are ready, or let me put it like this, we have to have the value chains that are ready to share these costs. And this is certainly a challenge going forward beyond the technical solutions that really develop readily all over the globe and everywhere in a lot of industries. But it has to be, the costs have to be absorbable. So we are really looking with our commercial departments now very thoroughly into the end markets where markets want to differentiate with lower CO2 footprint with recycling solutions. And that is crucial for us too, to run this concept we see here. Yeah, so that was it from my side. Thank you. So key statement is, yeah, green energy, green raw materials, but also let's do it together. Even a large company will not be able to do a circular economy to realize this alone. So we need partners here all across the value chain, the circular value chain in future. And yeah, I'm looking forward to cooperate further with all of you and a lot of other companies. Thank you.
Thanks a lot, Christian. Very, very clear presentation. And I think your third slide really gave a perfect overview of what it is about, different feedstocks, different recycling technologies. And I really take into account what you mentioned, that value chains must be ready to share the costs. I think this really makes sense. And also in view of the discussions that we have nowadays about expensive feedstocks that we buy elsewhere. And on the other hand, we have to take care of waste via different stakeholders, and they don't have to come on the shoulders of one stakeholder. And in that way, I think we can really come to a change. But I will come back to that in the panel discussion. Just one small, maybe tiny question on that very nice slide. I saw one circle indicating electrochemistry outside all the rest of recycling and feedstocks. And so I was attracted by that. Is there any reason why this circle is also appearing on that slide?
Yeah, thank you, Ludo. I think the reason is that we are in a quite ambitious transformation here. And I think this is also an innovation challenge, and we should definitely not forget competencies and technologies and solutions that might not yet play a super big role, but could be important in future. And we have a lot of competencies in electrochemistry, and it is, of course, a way to create chemicals, if you take green energy, with very reduced or no CO2 emissions. And I think this is for understanding these circles also important. No? We don't want to become fully circular on the expense of CO2 emissions. So you have to let this go hand in hand. And that is why electrochemistry might offer solutions that are really important. And it starts with green hydrogen, if you want a very simple reaction, so to say, and green ammonia, which is a base raw material for really large chemical players, which it's definitely looked into. But electrochemistry has much more to offer. So we are looking into this as well. Yes.
Thanks for mentioning this process intensification approach based on green electrons, green hydrogen, etc. I think it really makes sense as well. Thanks a lot, and please stay with us for the panel. So now it's time to really broaden up our scope. At the round table in the autumn last year on the use of wood in construction as long-lasting bioproducts, we promised not to limit ourselves to wood, but to look also in the future to the use of non-wood materials like bamboo as a fast-growing, strong and multifunctional material. And therefore, we invited today two experts from Vietnam, Hanh and Mr. Phu, and they will give us a first glimpse, if I can say, on the use of bamboo and the future use of bamboo for the future. And also this will be a kind of introduction for the World Bioeconomy Forum to expand its ideas towards Asia, to see what other opportunities that we have. You have seen when you look to the speakers in Ruka, that you see there's a lot of wood over there, but we have other places in the world where we can move on to bamboo. And so in that way, I would like to invite Professor Hanh. She's president of Research Center for Conservation of Natural Resources at the University of Sciences in Vietnam. And her research group participates also at the Museum of National Natural Histories in Paris and the University of Paris in Sorbonne on the taxonomy and classification of bamboo. And the second, the colleague is Professor Hyundai Phu. He's professor at Ho Chi Minh University of Technology as part of the Vietnam National University of Ho Chi Minh City. And he's the dean also of the Faculty of Materials. They will give a short presentation together, and I hope they can stick to 5-6 minutes. Hanh and Mr. Phu, you have the camera. And I suppose that Tammy will share the slides.
Hello.
Hello. Yep.
Good morning, everybody. So as for, I would like to thank Tammy and Ludo and everybody to leave us to participate. This meeting is very interesting on the bioproduct. So as for, I will present the slide, please. You see the slide?
Yeah, we see the slides.
Yeah. So as first, I would like to add, we are in the same university, National University in Vietnam of Ho Chi Minh City. So my work is on the field. So we collect many bamboo in Vietnam and in Laos and Cambodia to make a conservatory. And this is a source of bamboo to for Professor Phu to produce to transform his product from bamboo. So we work on the resource of taxonomy, like Ludo just present, and after that we work on the bamboo with the climate change, because the bamboo, this is a very good plant to fixation of carbon, and after that we make the root of bamboo, planting the bamboo on the different region, like in the soil in the center of Vietnam. They have no water. So you see in this slide, I don't know if you see this one. It is a green one in province Arisoy. So we are very happy we can plant on this, and it is a source of material very good for the transformation. So after that, we work on the education of the children and formation of the student in university and communication for people. So we create the small ambassador of bamboo in Vietnam for communicate many things about the environment. And we made the different products from bamboo, like floating house, like a new product from bamboo. This is for diet for the people. It is very good. And the arts from bamboo fiber. And now I would like to leave Professor Fu to present her work, his work on the production from bamboo. Please, Professor Fu, thank you.
Yeah, thank you, everybody. The Professor Hanh would like please share the slide continuous. Please. Professor Hanh, would you please?
You can see or no?
Yeah. I sent you the slide yesterday, and please.
Yes, this one.
Yes.
I show.
Yeah.
Can you see the slide on the top of the screen?
Yeah.
Okay.
You see or no?
Please continue to the slide the product from the bamboo in Vietnam, Professor.
Do you see?
I think Tammy can show our PowerPoint.
Yeah.
So you can talk about that, Professor Fu.
Yeah. Actually, from the bamboo in Vietnam, we are produce many products. For example, is bamboo wood is scrap from the bamboo, and the other product is some art handmade for some home station and for construction. The other product is from bamboo is the bamboo fiber, and the activity core. Everybody see the slide?
Yes.
I'm sorry. I will share the slide. Please wait a moment.
Sorry for this problem. I think
Yeah. Wait a moment.
You will see.
I will share slide.
You cannot see the slide.
Yeah. I will share slide. Easier.
May I ask just to finalize your presentation just by speaking and not by losing time on trying to share the slides? I think it will take too much time. So please,
Yeah,
Professor
I think
Fu.
so. You continue, Professor Fu, please.
Yeah, please continue, but without slides. It will take too much time.
Tammy cannot show the slide for everybody.
So
Hello?
please,
Hello.
can you come with your final?
Okay.
Can you come with your final message?
Yeah, right. The product from bamboo is in another word is bamboo wood. Wood DC from bamboo powder, activate carbon, furniture, home application, art homemade, bamboo fiber, and from bamboo fiber we can make the composite material from bamboo fiber, and the other is bamboo jar. One of the special products from bamboo is bamboo stone. It's made from Korea. However, in Vietnam, we just have some of the product we saw in previous slide. In Vietnam, we have not PC, wood PC from bamboo powder, and jar fabric from bamboo fiber and bamboo stone. The problem of bamboo product from bamboo in Vietnam is the from bamboo during production to get the product. We the production have many what is the bamboo fiber and what is some small pole and other. And most of factory in Vietnam is cannot use the wax to make a new product, and so they mostly using the wax to burn to get the energy. And if like that, the total economy from the total product from bamboo is lower. So we suggest the solution to the bamboo product from Vietnam. We use the bamboo fiber as a wax from the other production, and the leaf and the small bone in the slide to mixing with the polymer to make a bio-based polymer. There are two kind of bio-based polymer. First one is we use PE and TP to mix with the bamboo powder to make polymer, bio-based polymer material, and the other is we use biodegradable polymer to
Professor
make biodegradable.
Professor Fu, can I interrupt you and thank you, because we have to move on with the panel, and I will come back on what you last said, certainly in the panel discussion. So thanks a lot. I think I understood it quite well, and I will come back on that in the panel. So thanks a lot. Please join all together in the panel discussion. And first I would like to go again to Constance and to ask her if Constance, do you dare to say that recycling of bio-based plastics can really lead to a kind of carbon sink? We know that if we just do organic recycling of bioplastics, it is neutral. But if we keep the carbon in the system, can we really go then to a kind of carbon sink, taking into account, of course, that maybe 20% of the recycling will end up in non-recyclable residues? Is that an idea that is living also among the bioplastic world?
Indeed, we are talking about possible carbon sinks, and recycling can be, of course, seen as one option, but actually the preferable option is also to introduce bio-based polymers really in long-term applications. For example, there are projects in using bio-based polypropylene for pipelines, for example. Also in the energy sector for applications used in energy, like for the wind blades, for example, in the transport sector. Maybe this is the better opportunity to speak about carbon sinks for bio-based polymers.
And just a second small question. You mentioned about mixtures. In some cases, people that are producing PET, they say that PEF is really a problem concerning recycling, and so they try to protect themselves, if I can say. Is this really an issue, or do you think that the recycling of PET and PEF can be done together?
I mean, in general, to my knowledge, it can be done. I also know, as I said before, there are always concerns regarding contamination, but I have also met recyclers who are totally okay with having PEF in the PET. Studies have also shown that the quality of the material is not disturbed that much until a certain amount of PEF is in the PET stream. On the other hand, there's also the opportunity. The more PEF you of course mix with the PET, you get a changed polymer in the end. So you get more properties of PEF in the PET stream. You will not have a pure PET any longer, but you will have mixed materials. You have to, but I think you have to see if this is desired. Currently, there's just actually no PEF on the market. There will be just a very small amount in the market in the next couple of years, and then you just have to see how this probably develops.
Thanks a lot, Constance. And Ylwa, what is now really the driver for your company to expand your classical bioethanol refining towards other chemicals? You mentioned that you were stuck a little bit with these legal requirements, but on the other end, why are you still willing to do it? Is it really because there is a kind of market popping up, or how do you see that?
Yes, I mean, the market is requesting more and more feedstocks, that's clear. So, I mean, what I mentioned was a part of the deal, so to say, when you're selling it. But we are increasing the production, and we are looking now to go downstream to increase even more. I mean, we have the willingness and ability to become the greenest biochemical producer in the world. That's what we want, more sustainable. So really using also residues and cooperating with others, maybe using our technology to produce the residues as a feedstock to go further on.
So it's really based on a kind of consumer demand, if I can say.
Yes, we see definitely the consumer demand, and maybe it's also because the bigger companies are expecting something to come from Brussels. So since the Commission is driving Fit for 55, so they are preparing that part. But for sure, consumers are there and very, very interested nowadays.
Okay, thanks. Christian, are you also expecting something from Brussels, or are you expecting more from the consumers? I know you are not selling directly to the consumers, you are selling it to the manufacturing industry and the brand owners. But do you see this pressure coming up that you need to come with more recycled materials, with more bio-based materials? Is that really your driver? Yeah, we see that the CEO of Covestro is really mentioning that the company want to become a circular company. Is this driven by the consumers via the brand owners, or just by regulation?
Yeah, I would say by both. No? It's absolutely clear that regulations will play a very important role to shape the markets. And we hope, of course, that they are set very well in Europe, and we can also as a region go ahead and be a front runner in this circularity. On the other hand, without the end markets and the consumers, us at the end, but also the OEMs pushing in that direction, it won't work too. And we need also the financial stakeholders, by the way. No? And I think the chance now we have, and circular economy is not a new concept, of course. The chance now we have is to make it take off and realize it, because all these stakeholders seem to move in the same direction. But we, of course, need to align this very well to make it also then viable for all players. I think that's very important. And if you allow, Ludo, I wanted to make one comment on the recycling. I think bio-based polymers and materials and plastics, at least speaking for us, have to be recyclable too. That's absolutely clear. I mean, you don't want to have bio-based materials and then say, okay, now recyclability is not important, I can burn it, or maybe landfill it because it has embedded CO2, or it is biodegradable. I think that should not be the concept. It has to be recyclable as every plastic material and has to become a raw material again. And then you face the same challenges as for fossil-based material, actually. Yeah, and just to mention one again, for us, it is just the long-term usage. Yeah, we might have additives in our materials to fine tune and adapt the material to very specific applications that after 5 or 10 years are not usable anymore. So you need maybe to have a big analytic setup there, or you need different recycling technologies. But I would not at all go the direction that bio-based materials should prevent recycling. They have to tackle this area the same way as every other plastic.
I think most of the panelists will really agree with that, and I think this really is a very important statement, that we have to go to recyclability. And indeed, additives may change over time due to new developments, etc. So we must be able also to remove or to extract additives in a way that we can handle them in a separate way.
There's a lot of challenges, Ludo. If you just get me going now here, one comment more. There's a lot of challenges around this recycling, also on material homogeneity. You know that for plastics, for example, color is very important in some markets. And if the material you use as a raw material is not absolutely homogeneous, it's very difficult to get these colors right? So to make it end consumer friendly, or at least match the current requirements we have there, you need a very, very stable raw material source. And that is another challenge here when it comes to recycling. So we have to solve this together, working together with the recycling industry, allowing for a wide open range of processes. But this is something we have to tackle as an industry and as a society in a way.
And I think that if you allow me, that there is a link to the processing of lignocellulose, where we also are dealing with very strong chemical bonds with black color, etc. So in that way, I think these two activities can come together as well. I promised to Petro, and we are speaking now fully about recycling, to ask him how it is. Of course, his material is long-lasting. I'm not changing my bathroom every year, so it takes a long time, but there is also an end of life. And so my question to Petro is, how do you see recycling of these biocomposites in the future?
Yeah, well, I think that's the most challenging and critical question when it comes to composites, and not only in composites, but plastics and materials in general, that how can they be recycled, and has it been taken into account on the design table already? I've been following biocomposites and wood-based composites for more than a decade now, and it seems that there are a lot of composites on the market which seems to sell well because there is the bio prefix in the word. People don't really think that long what happens at the end of the life. But in my experience, having been doing this for 10 years or so, it's important that you take the end of life as a starting point when you design the product and the composite. So you choose the raw materials so that you know that you have some kind of end of life processing in mind, and you choose the raw materials so that you know that they will fit them in that processing. So in our case, for instance, we have chosen all the raw materials so that our products can be ground and used as raw material for MDF or particle boards. So it doesn't interfere in that process. And also we have chosen all the raw materials so that you can use the products as energy directly, because at the moment there is no logistics available for collecting our products and grinding and using them in particle board industry. But we have taken that into account. And when we are discussing with bigger players, like some large furniture companies in Sweden, for instance, so we can tell that we have taken this into account, and if you arrange the logistics, then we can have a full circle for our material and product. But my answer is that everybody should take this into account when they are designing the product and start from the end and go backwards.
Thanks, Petro. And this brings us immediately to the discussion with our Vietnamese friends, because they mentioned, if I understood it well, because the line was not so good, that they are making also these biocomposites of bamboo, which is similar to what Woodio is doing. And so again, maybe a short question, I don't know who can answer it, to Mr. Fu or Mrs. Hanh. Do you work also on recycling of composites of bamboo? There's somebody who can answer, who wants to answer, or dare to answer. My hand, are you still there? I think they don't hear us, so I will keep that question maybe for later. If we still see that we have connection with them, but I think indeed, yeah, my hand. So very short. Can you please very shortly answer? Is there any work ongoing on the recycling of composites that you're making with bamboo?
Yeah, we are working on recycling of the waste of bamboo. And
the waste
we
of
make
bamboo.
The waste of bamboo, because after when we make the fiber and the different products, we have many dust from bamboo.
And so this is a typical product that is then used in composites, and then I think that
the composite, and when I show you, we work on the tri-region, and we use this dust for compost, and this is very interesting because they fight against the erosion.
Okay.
And increase the organic matter in the soil. This is very interesting. Yeah.
Okay. Yeah. So I think that the next step is then to recycle also these composites, and I keep that for a next forum.
Very interesting about the presenter of Brucia.
Okay.
Yeah.
Okay, so we keep that for the discussion on the next forum somewhere in Asia. Thanks a lot. I would like to move now again to the studio, to Matthias, to ask if there is any question from the audience. Matthias, you have the camera.
It's actually Mark. Matthias has had to step out urgently, so I have a question for you. This was something that Christian said, which was that the value chain needs to bear the cost. How willing is the panel? Do you think the panel is that the consumer will bear this cost? What is the reaction to that question?
Yeah, I think we see a quite positive movement in many industries. Of course, not at the same speed and not with the same intensity, but also the end markets start to move. Of course, bio-based products offer CO2 footprint reduction, and beyond recyclability, CO2 footprint reduction are the major arguments also for OEMs to change their product portfolio and to go ahead. Of course, not in all industries at the same speed, not regions at the same speed. And of course, regulations can assist that or help that or force that. That is also part of it. But we see that moving. I only made this point because without the whole value chain moving together, also we as a big company cannot just invest and then let's say hope the best that somebody will buy that material. That is not possible. That has to go hand in hand. Also the supply, by the way, of bio-based raw materials to the chemical industry. I mean, there are other outlets, like aviation fuel and so on. So there is maybe even a competition, and to align this whole value chain up and downstream of us, that is, I think, the major challenge. But we would not be that positive on circular economy if we wouldn't see things moving now. Yeah.
Somebody else wants to react on this question?
Maybe I can report for the bio-based plastics industries. There have been different evaluations where it has been shown that consumers are for sure willing to pay a higher price if they really get the impression that they will buy a more sustainable product. You can also see this, for example, if you look at organic food. So people are willing to pay a higher price for organic food. What you also see is that a lot of bio-based packaging is already used for organic foods because it sometimes fits well together. And but it has been also shown, for example, for sportswear, for example. So if we have a product which is produced from bio-based fibers and it's clearly indicated that it saves carbon dioxide, has a better carbon footprint, then people are willing to pay a higher price, of course.
Yeah. Can I ask you, Constance, would you say that the end consumer like us has a higher willingness to pay for more sustainable product than the OEMs maybe?
Probably yes. Probably yes, because I think the decision making in our heads are different than in the heads from the OEM, where of course a lot of things are still very much cost related. Where I think consumers are more like, yes, if I buy the better product, I also get the better feeling, right? So I think OEMs are not led by
exactly. That's what we feel too. And that means the closer the OEMs are to the end consumer, the more they realize that there's a chance for them to differentiate as well, right? So
yeah.
That's an observation. Yeah.
And
Can I comment as well?
Ylwa?
Okay, thank you. No, but that's what Constance now said. That's the reason why I lifted this with like certification schemes where you have the boundaries and when you have the legal requirements, because the consumers, when they pay more, if they pay more, they want to feel the trust. They want to know what they are buying. So we have to give them trust. And we need a system where we are comparing in exactly the same way and lifting all the different kinds of arguments. And I think that's really important, so we don't have the mistrust. That happened a bit within the fuels. I mean, with the ethanol area in Sweden, for example, people started to talk about, well, it's not sustainable, it's produced with the coal in Brazil and blah, blah. Well, that was not true, of course, but we have to be very, very honest and open when we talk about it and compare in exactly the same way all the different parts in the value chain.
Can I comment as well?
Yeah, please.
Yeah, well, we have done some consumer studies about the consumer behavior when it comes to paying more for sustainability. And our understanding at the moment is that people, when you are interviewing a random consumer, everybody will say that obviously I'm willing to pay more. But in reality, when they are spending money, they don't spend a dime more just for sustainability. You need to get something more with the money. And this kind of, in our case, that's why we have positioned our products to premium category and we offer premium Scandinavian design at the same time. So you get the feeling that you are paying for something tangible. You get nice products. And I think this applies to Tesla is a good example. They have electric cars which are very expensive, far more expensive than normal family cars. But you get extreme acceleration. And I'm pretty sure that most of Tesla drivers, they won't admit it, but they are willing to pay 100,000 euros for a car because it goes from 0 to 100 kilometers in 3 seconds. So you need to get something extra. So you get this kind of feeling that, okay, I have a good conscience, but I'm still paying for a tangible feature or something in the product.
Okay. Thanks a lot, Petro. I think we are moving to the end, and I think the extra means performance. I think if we bring something on the market which is new, which is bio, then the performance must be at least as good as in the past. And if you can add something, then it really pays off, of course. Thanks a lot. I suppose, Mark, there are no other questions, or we have to close, I suppose, just to the studio.
No other questions. So now, if you can give your conclusion, Ludo, that would be fantastic. Thank you.
Perfect. Thanks, Mark. I would like first to thank the whole audience. I would like to apologize for some connection problems with Vietnam. It was a challenge for us, but we really wanted to broaden it up to other feedstock, and I think it was moving quite well at the end. We saw that bamboo could be used as composites as well as we do with wood. So we are learned today that bioplastics are on the move, and we understood fully that we are not only speaking about biodegradability, but about recyclability. We learned that they are it is possible to recycle them even in mixtures. There are possibilities to solve those problems. So this is really going on. We learned also that the consumers are really driving us towards more sustainable products, and that's one of the big reasons that we use bio-based products. And there was also a plea for legal requirements so that there is a trust that can be generated towards the consumers that are willing to pay more, but that they believe this is okay for us. And we also saw that value chains must be ready to share the costs. And I think that's maybe a point really to close this session. We are speaking about not just making a product, but also recycling it. And so it's the overall value chain, and everybody in the value chain must have a share of the benefit, but also a share of the costs. And I think really by doing so, and by making or assuring that the value chain is overall okay, that is really reliable, we can really move forward towards this bio-based materials in the way towards sustainable chemicals and materials. We also learned that we can also move towards bamboo. Bamboo is a fast-growing, high CO2 accumulating plant, and we see that a lot is possible over there. We learned that in the past, we mentioned that wood can replace concrete and steel. Some months ago, we showed you a movie that it can also replace glass. Today, we saw that it can replace also ceramics. So we are really moving and expanding this very strongly. And maybe the last word is that the focus concerning development, research and development is certainly on the recyclability of composites and recyclability of biocomposites. I would like to thank you all, and also especially the audience. And we are open, of course, for further questions that you can send us by email. And I would like now to give the camera back to the studio, because we are going to the lunch break.
Yeah. Okay, back to the studio. So sorry, Ludo, bringing some surprises. It's Jukka here now this time. So here we are. Okay, Mark is here together with me and Matthias, but all fine with our end. So thanks, Ludo, again. Excellent. Okay, panel you organized to us. It has been quite a journey. So okay, in the roundtable in February this year, this was about, as you said, you were talking about the long-lasting bioproducts. There was about the construction, how to store the carbon into the products. And this time, that was sort of, let's say, the linear long-lastingity. Now we were talking about quite a lot about the recycle. I like that topic, about the recycling. Okay, and there comes maybe a question to you that, the different industries do display different type of recycling rates. For example, pulp and paper, they are saying, 70% of the recyclability in the certain areas. Then on the other hand, steel industry can have a high recyclability. When it comes to textiles, we are talking about a couple of percentages. But how do you see that, is there any sort of low-hanging fruits, any industries that could then, catch up the recycling maybe easier than others? This is a big question, but I'm tempted to ask that from you. Do you see any industry, any specific areas where you can then, let's say, move a bit faster than others?
It's a very interesting question, but not so easy to answer, of
I know.
course. But,
sure.
As you mentioned very clearly, I think we have a lot of experience with the recycling of cellulose fibers. And this is really the example in the world. Everywhere in the world it is done. We know how it works. And we see that indeed we need 20-30% of virgin fibers to be added in the system. And I take always this as a kind of example to indicate that every recycling that we will do will need maybe 20% of virgin material that is coming in. Maybe I don't give a direct answer to your question, but what I see is that we have to focus on two lines in this. I think there are a lot of materials that maybe can better go to degradation. I mean, for instance, packaging that is in contact with food residues, etc. And the other one is all the materials that are already high performing, and they should be recycled. And we don't have to speak about biodegradation. But I had no time today in the panel. Wanted also to ask to Constance about maybe we must not speak that much anymore about composting, but we should move more and more to anaerobic digestion. Then we make biogas and we can use it as an energy source as well. Otherwise, we are just making CO2. Yeah. So I think there is a big difference, and there is certainly low-hanging fruit. We have a lot of collection of organic waste that is composted, and if we transform it into biogas, we see completely different situation. And I would like to refer to Novamont with Katja Bastioli yesterday, where Novamont is digesting the biodegradable bags with kitchen waste of the city of Milano, and they are doing that in Bergamo, and they are transforming the biogas into methane that is used as energy source, and in CO2 that is used by soft drink companies like Coca-Cola. And there you really make the circle completely round without any loss of carbon.
Indeed. There's a lot of potential, and there's also a lot of challenges, as was mentioned by Christian. So for the major industry to make that transition. So and it's so complex that in a way that it's not anymore like it was that Henry Ford used to say, any color so long as it is black. And even within the plastics, it is very important that you have really indeed the uniform quality, whatever you do. And plastic is just a perfect material. It's everywhere around us. So the transition is a challenge. And he said that it requires all our effort. We do need to do that together. So with these words, Ludo, thanks again. Thanks to your panelists. Thanks to Constance. Thanks to Ylwa, Petro, Christian, Hanh. You did a great job. We carry on a short, let's say, conversation also together with Aida. So thanks, Ludo, and here we are having Aida. So Aida, can you hear us?
Yep.
Okay. So hi, back here. So just before lunch. So what are your takeaways out of this morning session?
Just before dinner in Australia.
Yep.
It's so there are two interesting things that is my takeaway. The fact that bio-based plastics, the land use estimation for bio-based plastic is only 0.013. Of course, as opposed to the majority of the land use by others, which is majority is used by farming and agricultural industry, of course. I think it would be a good idea if there is some kind of a calculation to be made to calculate the positive impacts on the emission reduction for the production of bio-based plastics. Number two takeaway that was really interesting is for Ylwa, from Ylwa's presentation, that there is no sustainability certification available for bio-based products. And there's no real environmental impact reduction calculation as well. So without those two, how can we make claim, both sustainability and carbon claim for bio-based products? So those two are really, really big things that we need to figure out, Jukka.
Yeah, indeed. It is reminded also yesterday there was some discussion about this sort of also the regulatory pressure that it is also an effective tool that how you can then direct in the different directions. So and it is very, very sensitive. We all know that it's very sensitive. It is easy to say. So, but I think we are coming up about these topics in this afternoon session. It's late evening session for you after the dinner, after the lunch. So I think okay, we all deserve now having lunch break, and we will be back to you after 1 hour. So please stay with us.